air in our planet does not know of national borders or countries. A worldwide effort is needed so that what we do in the name of progress does not have a negative impact on our health and helps preserve the only home we know, Earth.
Chorus AQ combines satellite-type observations with ground observations and airborne observations to create the most complete picture of air quality we've ever created.
Explore with us. Take a deep breath and join us on an expedition that will investigate a major public health problem, air pollution.
One of the difficulties in understanding air quality is that the pollution that affects your health the most is not the initial component put into the atmosphere.
Under certain atmospheric conditions, some of these pollutants react with each other and produce new harmful agents like ozone.
There's three key ingredients to make ozone: NOx, hydrocarbons, and sunlight.
So think of ozone as an important cleansing agent from the atmosphere. When you have a big stain to clean, you use a lot of cleanser. And when you create a lot of pollution, a lot of ozone becomes evident in the atmosphere. That's helping to clean the atmosphere, but it's also impacting our health. We have primary pollutants. Nitrogen oxides and reactive hydrocarbons are most important in the formation of ozone.
Your car emits both NOx and hydrocarbons, sort of unburned fuel.
But the ozone itself comes from the chemistry, so we call it a secondary pollutant because it results from the chemistry that occurs after the emission of the nitrogen oxides and the reactive hydrocarbons.
When nitrogen oxides and hydrocarbons react with sunlight, they produce a harmful secondary pollutant, ozone. But wait, isn't ozone good for us? Well, it depends.
The role of ozone in the atmosphere is quite complex. In the stratosphere, ozone is a great benefit because it protects us from UV radiation. In the lower atmosphere, ozone is also a benefit because it's responsible for initiating the chemistry that cleanses the pollution out. But when pollution levels are very high, the chemistry runs amok and you create very high levels of ozone. And those ozone levels can become so high that they become reactive with our own body tissues and become a problem in terms of health.
Photochemical smog is considered to be a problem of modern industrialization. It is present in all modern cities, but it is more common in cities with sunny, warm, dry climates and a large number of motor vehicles. It can also affect rural areas, where agriculture, trees, and forest fires can release a considerable amount of volatile organic compounds, or VOCs.
What are the sources of VOCs? Well, we have just the evaporation of gasoline when you're filling your tank, petrochemical plants, the refineries that are making gasoline for us from oil, and also the plastic companies that are making plastics, polyethylene, polypropylene.
In terms of reactive nitrogen, man's activity far outpaces the natural sources, and so we can say that when nitrogen oxides are present, that's man. When you talk about reactive hydrocarbons, actually vegetation plays a major global role in creating them.
Trees can emit that pine tree smell you smell, but also a lot of the deciduous trees are emitting isoprene. Isoprene is very reactive and very good at making both particles and ozone.
But fortunately, they create very specific molecules, and when man creates pollution, it creates a different chemical mix. And so we can look at the constituents of the reactive hydrocarbons to determine whether it's nature or whether it's man.
But because these compounds travel with the wind, they can affect different parts of the world. Recently, scientists from other airborne campaigns were able to trace the origin of unusual high levels of ozone in the air above the western Pacific Ocean. They found that they were linked to the organic compounds released by forest fires in Southeast Asia and Africa, half a world away.
The atmosphere is a shared resource, and we're seeing more and more that the entire northern hemisphere is suffering from pollution background levels that are due to all of us, not just one.
Everyone living in a big city around the world is breathing polluted air, and it is having an impact.
It's part of the tug of war between progress and the price that we pay for that progress. And so that balance needs to be maintained into the future as we continue to develop economically, develop technologically. We have to pay attention to how that's impacting the air quality.
Our world is an interconnected system, and the impact of air pollution goes beyond the air we breathe.
All of the processes that are emitting and causing air pollution are also putting CO2 into the atmosphere, causing climate change, global warming.
It also affects our soils, our glaciers, our oceans, our climate.
And this is a problem that's going to affect our children and our grandchildren. So it's very selfish of us to ignore this long-term problem that is created by us.
In a laboratory setting, you can artificially control different parts of the problem, so each effect can be isolated. That's hard to find in nature.
Seoul, South Korea. A megacity with over 25 million people and a population density which is almost twice that of New York and 8 times greater than Rome. Despite being a modern and massive megacity, South Korea still counts with many forests and rural farming communities throughout the country. But why is South Korea an ideal natural laboratory to carry out air quality studies?
We have a bunch of factors. We have a very large city, a mega city, the 4th largest city on the planet, with lots of cars, lots of power plants. And then downwind from that, we have a forest. So we have the urban plume reacting with the natural emissions from the forest.
This is a perfect place on the globe to try to understand how the mixture between man's emissions and nature's emissions can create poor air quality.
Air pollution is an important environmental problem in modern societies. The rapid growth of new economies and industries in developing countries makes it very difficult to address environmental issues.
Korea has been developed very quickly after the Korean War. Actually, economic success gave us lots of benefits to the people. However, this also brought many environmental issues, including air quality.
So general public has been known about the yellow dust issue before, and in recent they start to learn about the fine particle issues and ozone issues. They're starting to pay their attention to those newer issues emerging to our society.
Korean government has been making persistent effort to improve air quality. We participate in this project as though understanding of current situation with aerial, ground, ship, on the top of current simple ground observation, crucial in future improving air quality.
We are definitely pay attention to solve this issue, and general public wants to know how we can actually achieve that goal.
Developing effective strategies to balance the economic growth and the good health of the population is key to continue growing and prospering as a society.
Unfortunately, policy always lags emissions, and so it usually takes time to understand what's causing the poor air quality, and then regulations can take effect.
It's a tough problem. We haven't solved it completely in the U.S. But here, I think you're right. We're learning a lot more about the specific sources in this area so that here locally the government can decide what's the most effective strategies to use, because we don't want to hinder economic development. We just want to know what are the smartest choices you can make so you get the best bang for the buck.
In the United States and in Europe, this has taken place over a long period of time. Things in Asia are growing very rapidly, and so we're in the middle of that process.
But the difference is that now, with our knowledge and technology, we are better prepared to address these complex environmental issues.
In these days, many countries in East Asia have been developing very quickly as well. Chorus AQ mission makes people aware of the seriousness of current air pollution.
So we are thinking, based on this mission, more general understanding, getting better and better, and eventually we can find something to actually reflect to the strategy.
Chorus AQ mission results will help develop improved ways to assess this challenging task.
Current investigation will definitely help us gain deep understanding of air pollution phenomenon in global scale.
This is a lab. Measuring instrumentation, probes, sensors, gas and liquid chemicals, computers. Yeah, this is a lab, but maybe not the lab you would expect. Meet the NASA DC-8 Airborne Laboratory.
The airplane is designed for different instrumentation suites depending on the missions that we fly. So we have multiple zenith ports that look up, we have multiple nadir ports that look down, and of course many of the window blanks there.
There are 25 instruments on board the aircraft, not only from NASA, but from many universities and other government labs and organizations. And together they paint a picture of the atmosphere that can allow us to completely evaluate what emission sources in the peninsula are contributing to poor air quality and how the chemistry actually works in terms of the outcome at the end of the day when ozone and particles are such a concern.
Yeah, this integration is about as big as we do, and if you've seen on board the airplane, you can see it's very full with all the racks and most of the windows, covered with the in situ probes that are there.
The Chorus AQ campaign will gather air quality data in and around the Korean Peninsula from multiple sources, such as ground stations and maritime sensors. However, the Chorus AQ aircraft will be the ones to provide the most detailed information over a larger geographical area and at different altitudes.
So in order to understand how it all works, we have several aircraft that we have to fly. One is the one I'm standing on right now, the NASA DC-8. The DC-8's role is to measure the atmosphere directly. From this aircraft, we can measure literally over 100 different compounds in the atmosphere.
The airplane flies as easily at 500 feet as it does at higher altitudes. That enables us to do both remote sensing, which is using radars or LiDARs, as well as we can fly lower, we can do vertical profiles with our in situ sensors, which is currently what we got mostly on this airplane.
In order to understand the atmosphere, there are many different molecules that we have to measure. The satellite will not see all of them. And so by being able to measure what the satellite will see and at the same time see all of the details, we can begin to understand what sources and what meteorologies and what combinations of conditions will affect what we see from space.
By combining detailed measurements from aircraft with those made by satellites, we can get a better picture of pollutants in our atmosphere.
So this aircraft carries instruments that work just like the satellite instruments. The higher we fly, the wider the patch of Earth we can see.
During the campaign, NASA King Air aircraft will mimic the measurements future satellites will make.
We fly at about 28,000 feet, and at that altitude we see about a 5-mile wide patch of ground. Like mowing the grass, we're just trying to cover a patch on the ground continuously and make a map of what the pollutant distribution looks like.
So we have a small King Air aircraft flying above all throughout the day, measuring the way the future satellite will measure air quality. Meanwhile, the DC-8 flies underneath, showing what the distribution of pollution is above the ground. That allows us to understand how to connect what the satellite sees with what's at ground level.
Chorus AQ has in its team 2 smaller aircraft equipped with atmospheric chemistry measuring instrumentation. A King Air from NASA Langley Research Center and a King Air provided to the Korean National Institute for Environmental Research by Hanseo University.
Hansa King aircraft is relatively smaller than DC-8 in NASA. It can freely access source of pollution and measure air quality capital territory that cannot approach using DC-8.
Working all together, scientists from the Chorus AQ campaign will provide valuable data and test the technologies needed to better understand air quality and the flow of pollutants within our atmosphere.
We can only fly the planes for a very short period, but the details that you get from the aircraft help inform the observations from space and from the ground and how models can interpret those observations.
From this mission, we'll have better models and better mission data for Asia, and so we'll be able to extend the usefulness of this well beyond South Korea to other developing cities around the world.
We have the tools to study our atmosphere. Now, let's go exploring.